So this is 1676 here, and we have this linkage set up, and we're going to try to look for this omega AB here, is what we're trying to find. And we know omega CD is 5 radians per second. Okay. So in non-vector notation, we know the velocity of B, right, is just omega times 6, right? But we're going to write all these velocities as vector terms. So the vector, the velocity of B, right, is equal to omega AB, the vector omega AB, cross the vector to B from A, or B with respect to A. Okay. The way that this is drawn here, right, that is in the clockwise direction, and which clockwise we have usually called negative, and the vector that it rotates about is the z vector, or the vector coming out of the page in the k direction. So that's a negative k vector. So we have negative omega AB in the k direction, cross with this vector from B to A, or I'm sorry, from A to B, and that is just 6 inches in the I direction, cross 6I here. Okay, so we have that equation set up. We don't know the velocity of B, and we don't know omega AB, so we're going to keep going. We do know that the omega CD is 5 radians per second, so we could write the velocity of C is equal to omega CD in the vector terms cross the vector from D to C, or C with respect to D. All right, and that vector this is 5 radians clockwise around the positive k direction. So we have 5k, that's omega CD, 5k cross the vector from D to C. All right, so in the I direction, or the x direction here, we have negative 4 cosine 45 degrees in the I direction, and then in the y direction here we have 4 sine 45 degrees in the j direction. Okay. All right. So we have the velocity of B and the velocity of C. What we want to do is, if we can find another equation for the velocity of B, we can solve for omega AB. And we can do that. The velocity of B is equal to the velocity of C plus the velocity of B with respect to C. Okay. And we can write the velocity of B with respect to C as nothing more than omega BC cross R to B from C. Right? We can have that. And we've already have an equation for the velocity of C here. So let's write this out. The velocity of C plus, what is this, omega BC. Omega BC, and that will be in the K direction, cross this vector here from C to B, which is 8 cosine, is that 30 degrees? I'm sorry, 8 sine 30 degrees. 8 sine 30 degrees in the I direction, plus 8 cosine 30 degrees in the J direction. Okay. So writing this all out, we have negative AB in the k direction cross 6I is equal to 5k cross negative 4 cosine 45 degrees I plus 4 sine 45 degrees j plus omega BC k cross 8 sine 30 degrees I plus 8 cosine 30 degrees j. All right, so that's a long equation and it requires 3 cross products. So if this side of the equation will have no component in the I direction. So if you take a look at this, if we do the cross product here, if we were performing the cross product here, we would block out the I direction. We'd have no component in the I direction here. So the I direction equation is 0 equals negative 14.142 minus 6.9282 omega BC. Okay, and then in the J direction, we get negative 6 omega AB equals negative 14.142 plus 4 omega BC. So these two equations are critical to solve for omega AB. So omega AB then comes out to be 3.72 radians per second, and omega BC is negative 2.04 radians per second. And that is the solution to 1676.